So far, we've been talking about the shape of data, which we classified as either symmetric, skewed to the left, skewed to the right. We've talked about measures of center, which are our mean, our median, and our mode. We've talked about a couple measures of spread, being the interquartile range, or Q3 minus Q1, the range, the max minus the min, and today we're going to add in another measure of spread, and that's going to be the mean absolute deviation. So the mean absolute deviation formula is going to be x1 minus the mean. We're going to take the absolute value of that, add it to x2 minus the mean, and add that to as many data points as I have. So we're going to call it x to the n minus x bar. And then we're going to divide all of this by n. And this formula looks very daunting and like it's going to be quite difficult, but it's really not near as bad as you think. And just know that x1, x2, x3, so on, all the way out to xn are the elements of the data. And n is going to be the number of elements in our data, where x bar is going to represent the mean of our data. And we know that from when we found measures of center, that in the calculator, x bar is denoted as the mean. So the easiest way to tell you how to do this is to just look at some examples of what we're going to do here. So let's look at the first one. We have a table and it shows the recent population in millions of the 10 largest US cities. So the first thing I'm going to want to do is take these 10 values right here and put them into my table. So just list those 10 x values. 1.5, 3.8, 1.3, 1.6, 2.9, 1.4, 0.9, 2.3, 8.4, and 1.3. The next thing we're going to need to do is to find the mean of this data set. So you need to take your calculator, hit the data button, enter these 10 values into L1, then you need to hit second data, and then you're going to look for option 2, which is 1 bar stats. You're going to then hit enter and enter 3 more times, making sure that it's highlighted around L1. And then in the list, you want to look for X bar. And the X bar is going to be what our mean is. So this is a perfect time to pause this video, put it into the calculator, and find the mean. If you don't have the black calculator, you can go to desmos.com, desmos.com, use the graphing calculator option, and if you type in mean, M-E-A-N, parentheses, then you enter your data set with commas in between. So 1.5, comma, 3.8, comma, 1.3, so on, and hit enter. It'll tell you what the mean is. So pause the video here and find the mean. Now that you found the mean, you should see that it is 2.54. So what I'm going to do every single time in this middle column, deviations from the mean simply means the difference, or the value between those two. I'm going to do 1.5 minus 2.54 and write my answer in this column. 3.8 minus 2.54. 1.3 minus 2.54. 1.6, and I'm just going to write down the exact value that I get. So this is a great time to pause the video, to do these subtractions and write it down. And then when you hit play, make sure that you have the same values that I do. All right, now that you've done all your subtractions, hopefully you got these values. Remember, if the x value is lower than the mean, when I subtract it should be negative. If my x value is higher than the mean, when I subtract it should be positive. Now we're going to fill in this last column, and it's finding the absolute value of the deviations. So remember, this is called mean absolute deviation. We found the mean, we found the deviations. Now we need to take the absolute value of these deviations, and then finally we'll find the mean again. So definition of absolute value is simply the distance from 0. So we know that distance cannot be negative. So all I'm going to do here is, if my value is negative, I'm going to change it to a positive. But if my value is positive, I just leave it because that is a viable answer. So I'm just changing any negatives to be a positive, and I'm rewriting any positive that I already have. And the last step is we need to find the mean of that last column. So what you're doing is you're finding x bar of the absolute value of x minus x bar column. So this would be a great time to pause the video, and you're going to take all this data right here and put it into the calculator. And again, you'll go to data, enter it to the L1, second data, one variable stats, look for x bar using these numbers, or you'll go to desmos.com and you'll type in mean and then use this as your data set. So press pause, put this into your calculator. When you hit play, you'll be able to see what the math is. Now you should have found that the mean absolute deviation or the MAD for short is 1.496. So there's a couple things we need to know about the MAD. Very important for you to write in your notes. That the mean absolute deviation can never be negative. We know that because we've taken the absolute value, which means we've removed every negative from the problem. So this is very important that the MAD cannot be negative. The other thing we need to know is the smaller my MAD is, means the closer together my data is. This is why it's a measure of spread, because it helps me tell how far apart the whole data set is. So again, the smaller my number of MAD, the closer together the data set is. And these are relative based on two different data sets. I can see that 1.496 is small, meaning my data set was close together, but compared to 0.96, this would mean a farther apart data set. For this next example, they're asking me to compare the calories in several sandwiches at two different restaurants. And so we're finding the MAD for each. So what I'm going to need to do is create this table for Susan's sub shop and also create the table for the picnic basket. So I'm just going to do this here in Susan's sub shop. I'm going to list my data points. I'm going to take the data values from Susan's sub shop, 490, 380, 270, 430, 510, and 410. You want to type these into the calculator into Desmos and find the mean. So pause the video, put them in the calculator, put them in Desmos, and find the mean of our data set. Now that you put these in your calculator, hopefully you found the mean to be 415. So the second step is to come and subtract 490 minus 15, 380 minus 415, 270 minus 215, 430 minus 415, 510 minus 415, 410 minus 415. We're going to put those values in this second column that we're going to create. So pause the video and do those calculations. Okay, once you subtracted, you should have gotten these values. The next step is to take the absolute value of each. So again, if it's positive, I leave it positive. If it's negative, I change it to a positive, because this is distance from zero, and distance cannot be negative. So now that I have all my positive values, the final step is to put these into the calculator, whether it's Desmos or your block calculators, and find the mean of this. So pause the video, take some time to put this into your calculator. And you should find that the MAD of Susan's sub shop is 61.67. Now we want to do the exact same things, but we want to do it with the picnic basket. So I'm going to take my values from the picnic basket. 550, 320, 470, 430, 610, 290. I'm going to put all these things in the calculator and find the mean. So pause the video, use your calculator, find the mean. You should have found that the mean is 445. So now we're going to go through 550 minus 445, 320 minus 445, 470 minus 445, 430 minus 445, 610 minus 445, and 290 minus 445. Take a moment, hit pause, put this in your calculator, and record your answers. All right, hopefully you got these values: 105, negative 125, 25, negative 15, 165, negative 155. Our final step, or the next to last step, is to take the absolute value of these. So again, if it's positive, I just rewrite it. If it's negative, I write it as a positive because we're discussing distance from 0. 65, and then 55. And then I want to calculate the MAD, meaning I need to take this last column, put it into my calculator, and find the mean of that last column. So press pause, take some time to put that in. You should have gotten your MAD to be 98.33. So our question asks, what does the MAD tell us about each of our data sets? Well, it tells me that Susan's Sub Shop sandwiches are closer in caloric intake. For example 3, we're going to put together everything we've done so far in this unit. So the chart shows us the average age of people at a meeting. They want us to find the measures of central tendency, so the mean, median, mode, the range, the max minus the min, the IQR, Q3 minus Q1. They want us to also create a box and whisker plot and then determine if there's any outliers that exist. And finally, find the MAD. So I know from this list, we first need to make sure we have everything we need to find. We need to find the mean. They told us we'll have to find the MAD. And in order to find the box plot, remember we need the 5-number summary. So that'll be the minimum, Q1, median, Q3, and the max. In addition, they want us to find the mode, so the other measure of central tendency, the range, max minus min, IQR, so Q3 minus Q1, and finally they want us to test for outliers. Now if you remember, by putting things into the calculator together, if you go ahead and enter your data set into L1, you can find the mean, the min, Q1, median, Q3, and max, all by putting your data in at one time. So go into your calculator and enter 26, 26, 33, 22, 25, 30, 40, 30, 23, 27, 26, 25, 30, 41, and 24 now, and find all of these things. So pause your video to find these answers. So now that you put this in your calculator, hopefully you found that the mean is 28.53, my minimum 22, Q1 was 25, my median 26, my Q3 30, and my maximum 41. Now we can't find the MAD yet, we're going to have to use our table, so we're going to skip it for now. The mode is going to be the values that occur the most often. And if I look, I have 26 that occurs 3 times, but I also have 30 that occurs 3 times. So this is going to be bimodal, meaning there are 2 modes, and the 2 modes are 26 and 30, because they both occur the same amount of time. Remember, the definition of range is the maximum minus the minimum. So for my range, it's 41 minus 22. And when you do this, you get an answer of 19. My IQR is going to be my Q3, so 30 minus Q1, which is 25, which tells me that the IQR is 5. Now remember, there's two formulas we have to use when testing for outliers. The first one is for a lower fence of the outlier, so I'm going to use Q1, which is 25. I'm going to subtract that by 1.5 times the IQR, which was 5. Remember, 1.5 represents a box and a half away from our data. For it to be significantly different, it has to be under the box and a half. So hit pause, type this into your calculator, and we'll find the lower fence. So when you put that into your calculator, you should have gotten 17.5. So what I'm looking for in my data set is any number that is 17.5 or lower. And we know that we don't have that since our minimum was 22. Then we want to test our upper fence, which would be Q3, 30 plus 1.5 times the IQR of 5. So pause the video, type this into your calculator. We find the upper fence to be 22.5. So what this means is I'm looking for any number in our data set that is greater, and that's not correct because that's going to be lower than my Q3. So I used a subtraction sign in my calculator. Be careful not to do that. Remember, it's 30 plus 1.5 times 5, which should give me 37.5. So now I'm looking for any number in my data set that is 37.5 or higher. And if I look, we have two values that are 37.5 or higher, and that is 40 and 41. So both of those will be my outliers. Now, while we're continuing on the trend of our 5-number summary, we might as well go ahead and make our box and whisker plot. Remember, you have to have a number line that is labeled. You cannot just let it be a floating box. I've chose to make my number line go up by 1s. So I'm going to start at 22, and I'm going to label my number line all the way to the end. Okay, so now that I've labeled going up by 1s, we just want to use our 5-number summary. My minimum is 22, my Q1 25, median 26, Q3 30, and my maximum 41. You just want to connect everything. Remember, the Q1, median, and Q3 all go in the box. Then max are just connected with a line. So at this point, now that I have all these things written down, I can go in and find my mean absolute deviation. So I know that I've got my number list over here already written down in a chart. I'm going to subtract everything by 28.53. So at this point, go ahead and do this in your calculator, hit pause, and make a list for your values when you subtract the data set from the mean, or the mean from the data set. Now that you have all those values subtracted, again, you want to take the absolute value of those things. So anything that's negative, you want to change to a positive. Write those things down. This would be a great time to pause your video and type all this into your calculator and find the mean again. When you've done all that, you should find that the MAD of the data set is actually 4.3793. And you can round this to 4.38 if you like. Final thing we need to discuss here is if we just have a dot plot, how are we going to be able to evaluate which figure has the smallest MAD, which one has the largest MAD? Meaning which one has the least variation, the smallest MAD, and which one has the most, which would be the largest. So just by looking at it, we can tell that the data set that is closest together would be this option number 2. So we would say this has the smallest MAD or the least variation. And if we look, the data set that is farthest apart would be this third one, and it is going to have the largest MAD or the most variation. One way to go and check yourself is to create a data set for each of these, reading the dot plot. So for this first one, it would be 2, 3, 3, 4, 5, 6, 6, 8, 8, and then go through and find the MAD for that. So pause the video, find your MAD for this first data set. And you should have gotten that your MAD for this first one is 1.7. Now I'm going to do the same thing with the second data set. So 4, 4, 5, 5, 5, 5, 5, 8, 8. And if you've read the instructions here, it helps you because it tells me the mean of each data set is 5. So really all you have to do is go in and subtract each of these numbers by 5. So pause the video, find the mean absolute deviation for data set number 2. And you should have gotten that your mean absolute deviation was 0.44. Then we want to follow suit and do the exact same thing for the last data set. So we have 1, 1, 1, 1, 1, 10, 10, 10, and 10. Again, you know the mean is 5. You want to hit pause, find the mean absolute deviation. And you should have found that the MAD for this last one was 4.4. So our observations were correct that we made. We tested it by actually finding the mean absolute deviation. So the steps, you want to find the mean first, subtract each data point and the mean. Any negative value you have, turn it positive, and take the mean of that last data set that you get. And that's how you find the mean absolute deviation.